What is going on, guys? Welcome back to the next video in learning discrete mathematics. My name is QDS and you guys watching my channel Coraiwood. Alright, so in this video we're gonna see what is special sets. The first one we're gonna see that we denote O and there is a cross there. We see that one that we call this one is empty set. As we've seen in the previous video, is a set which contains no elements. And some mathematicians they put it curly braces open and close for empty sets. So when you see this one is equal to the same one. So when you see O, there is a cross here, it means that's empty set. And once you see that is empty, especially in computer science, because in computer science we can denote this one in computer, but when we put it, say for example A, and I'm going to put it A for example, and when we put it this one and we do this one, it means that's an empty set. And especially if you're doing C++, you need to put this one, it means that's the end of the line. This one's comma, it means that's an empty set. That's especially true in computer science because we can put it O and we can cross the line here, so we can't do that. So we see this one as an empty set which contains no elements. And what is the letter U? This one is a universe set, is a set of all elements. When you see this U is the universe set, is the set of all elements. Okay, so now we're gonna see this one, the set N, and we're gonna see 0, 1, 2, 3, and there is epsilon here, the set of all natural numbers. So I have there is all, see this one as all natural numbers. So this N is the natural numbers. Okay, so the set Z, and we're gonna put here, we keep in mind we have 0, and this 0 is Z is we have minus 1, 2, 3 epsilon, and we have 1, 2, 3 epsilon is the set of integers. So now this one, you guys think of this one as there is a line here of big massive line here where this one have a 0, which this guy is going to be here, and here minus 1, minus 2, it's going to be minus 1, negative 2, and we have a negative 3 here, and that's how we're gonna 4, 5, 6, 7, and whatever the epsilon represent here. And here we have a 1, we have a 2, and we have a 3, and we have a 4, 5, 6, 7, 8, 9, whatever the epsilon says. Okay, so the whole numbers is we're going to see this one, and we're going to represent this one by the letter of Z. This one is the natural number, this one is the set of integers, and that's the set of integers. That's how you guys are going to write this one. And there is a 0 in between. Think of this one as a graph. As I say to you now, think of this one as a graph, which in the middle there is a 0, and this one goes negative number towards the left, and we have a positive number goes towards the right. So that's the basis of the mathematics, because when you guys minus something, you guys go towards the left, and when you guys do say addition, you guys go towards the right. And the set of Z is the set of all integers. So I'm gonna clean this one. With this one, but not all. Alright, so the set of P is 1, 3, 5, 7, 11, 13, 15 is the set of all prime numbers. So that's how we going to denote the prime numbers. And here the set 2Z, because the 1Z is integer number. What the heck is this 2Z? This 2Z is the set of even integers. Okay, so what about the Q? Because we haven't seen the Q before, as a set of rational numbers. And what is the rational number? And a rational number is a number that can be written in the form of whatever fraction. You guys see this one of 2 integers. So we have an integer here, and we have a fraction Okay, so we haven't seen a fraction. The number can be represented as one integer divided by another integer, but not zero. Keep in mind, we can't divide it by zero. Say, for example, we can put a 1 over, for example, 4. That's a fraction. We can put a 6 over 1, 10 over whatever number you guys can think of. You guys can put it like that. And we're going to say, for example, 20 over, for example, 4. So this one is integer, this one is integer, and as I said to you guys, a rational number is a number that can be written in the form of a fraction of two integers. So the first one is we have integer, and the second one is we have integer. So the rational numbers is a subset of the set of real numbers, share all the properties of real number. And soon we're going to see what is a real number. If you guys haven't heard of the closure, that's a U. One of the properties of rational numbers that separates them from their irrational numbers is their property of closure. Rational numbers are closed under the operation of addition, subtraction, multiplication, division. What we mean by this is whatever you guys perform, say for example 2 plus 2 equals to, for example, 4. If you guys look closely, this is integer, this is integer, this is also integer. So as a result, doesn't matter what you guys do. Say for example, you guys gonna say for example 6 multiply 2, for example, you guys gonna see here the results is gonna be always integer, regardless of what you guys gonna, which one you guys apply here, which form of operation, arithmetic operation you guys apply here. You guys gonna put plus, minus, multiplication, you guys gonna division, whatever you guys gonna do, the results always going to be integer. So we have a 12 here, and this 12 is integer. So all the results, whatever we're going to see, are rational numbers, and the result of this operation will always be rational, given that the initial of two values are rational numbers. And there is another one. I'm going to tell you guys about the inverses. So because that's also related with these rational numbers. Say for example, a rational number can have additive inverses. For example, we have x and y. I'm going to put a, for example, minus. We put a x here, and we put a y here, and now here is also equal to minus x over y. So as I said to you guys, given a non-zero rational numbers, x over y, the multiplicative inverse is and the multiplicative inverse is x over y. Sorry, that's x over y, and we put a negative 1 here, equal to, we put a y over x. So the first one is the additive inverse, and the second one is the non-zero rational numbers, x over y, and that's a multiplicative inverse. This one, that's how you guys multiplicative inverse. And here the result is that you can put a y over x, and here you guys can put a negative goes here over y. And in the second example, this guy here, that's a multiplicative inverse, and you can put a, say for example, this is x, and keep in mind that's x. So that one, I'm gonna write it again, x over y, and that's a negative number here, and we can write this one as this is a multiplicative inverse. We can put a y over x. So that's how we're gonna map this relationship. That I'm not gonna put this 2z here, and I'm gonna put the first one is, we're gonna see this one n, this one is n, that one's inside this integer. Then that's how we're gonna put it as z integer, and that's what we're gonna come next as rational numbers. So that's ones we're gonna come and put a q here. All right, so the next one is we're gonna see all of them is gonna be the subset of real numbers, and the real number is gonna be here soon, and they're all gonna be under the complex numbers. And in the future videos, I'm gonna show you guys about the complex numbers, but keep in mind that's how you guys visualize this one. So I'm gonna get rid of this one. Alright, so as I said to you before, the set of real numbers. Now we're going to see the set of real numbers. So we have here a real number, and we denote this one with R. This one, the rational numbers, we denote with a Q. What is a real number? We have a real at the front, and we have a number. Real world number, anything that can be found in the, say, around you, that is a real, like objects. That's called real number. That's the simplest definition I can give you. The find the numbers everywhere, whatever you can see around you, that's and whatever you guys can count around you, that's a real number. So the natural numbers here on top, as you guys can count your say for example your fingers. We have a 5 fingers on the left, we have a 5 finger on the top. So when you guys count that one's going to be the natural numbers. With the natural numbers we can count objects, but we see here with the rational numbers, we can't count the natural objects, but we can do the fractions. I haven't discussed with you guys irrational numbers. Irrational numbers are numbers that we can count. Say for example, we can calculate the square root of a number, or we can measure the temperature, we can see Fahrenheit and centigrade. That's irrational numbers. So now we're going to come back to real numbers. Whatever numbers you guys can think of around you is a real number, except the complex number, and we put it this one as R, like this is the union of the set of rational numbers, which we put it as a Q. And keep in mind that the real numbers can include the rational numbers like positive and negatives, or integers and fractions. We have a properties of real number, and that's very long subjects. We have a closure property, we have associative property, we have a commutative property, and we have a distributive property, which I guarantee you guys, which I'm gonna discuss with you guys in the future videos. But for now, we're gonna visualize how we're gonna put the set of just like integers. We're gonna put the display, how to represent that that one, the graphs. Alright, so I tried my best to put this way. Say if you want to visualize this one just like integers, here we can put a 0 in the center, and now we can go over say for example 1/2, and this ones we can put a 1, that's half, and we can put a 3/2, and here we can put a 2 here. So that's 1. Keep in mind that's 1. And what about here? That's 1. How we going to come here? We can put a 5/2. We can put a 5/2, and here we can put a 3. Okay, so if I want to push it further, I can put a 7/2. 7/2. Okay, so now in the negative side, which we go this way, is I'm gonna put a -1/2, the same one, but we're gonna apply -1/2. This one I'm gonna put a -1, and this one I'm gonna put a -3/2. So that's -3/2, and that's a 2 here, and we can put a 2 here, -2. And inside here we can put a -5/2, 5. Keep in mind in general mathematics we say that 5/2. That's how we're going to read this one to make it quicker. And we can put a 3, -3, and here we can put a -7/2. So we put a -7/2. That's a 7. And we can put a 2 here. So the 0 here is origin. We call this one origin. So the real number can be, as I said to you guys, positive this way, or it can be negative. It can be rational numbers, or it can be irrational numbers, and it can be algebraic number, or it can be infinite digits as well, such as 1/3. 1 over 3 equal to 0 point, then we're gonna say 0.33333 all the way to infinity. We can see this one as well. We can go all the way to infinity. We can reach to the, say for example, if you go further, we can reach to e. Then we can reach to the pi number here if you go towards this way. But if you go towards this way, as I said to you guys, in one point we guys going to see to the e, and 1.2 we're going to get to the pi. So why we call this one real numbers? And as you remember from the earlier slides, it's opposite to the imaginary numbers. We cannot imagine this one because this is a real, like a real numbers around you. All right, so as we discussed the imaginary number, we can denote the imaginary by, say, I. That's called imaginary number. Imaginary numbers. So I is for imaginary number. So an imaginary number, if you square a real number, you always get a positive or zero result. For example, if you do 2 multiply 2, you get a 4. For example, if you do, again we gonna do this one, 2 minus 2. If you multiply minus 2, we got a 4 again. So we're gonna put a minus 2 here. We're gonna get a 4. If we have this, then why we need a imaginary number? And we can see imaginary number solves a lot of problems too. They just don't imaginary numbers. Say for example, we have a square root of, for example, minus 9 here, and we're gonna get it minus 3i, minus 3 imaginary number. So that's what is very useful. So what about now you're gonna ask me what's the square root of, say for example, minus 1. We have a minus 1. What's the square root of minus 1? And we're gonna put sometime minus 1 as we put a like that square root, and we put a as an exponent 2, and we put a minus 1. That's I stands for in computer science for imaginary number. I is for imaginary number, as I said to you in the previous video, that you can imagine. Normally x and y, our I in computer science, say for example, if we go in a loop, we say for example for I in whatever. So in, if you guys want, because this I stands for imaginary number in x or in y, that's in computer science. If you guys doing computer science, that's how we can imagine this number. But they are very useful, especially with algorithms and machine learning. These imaginary numbers are very useful. So now we're gonna come and we're gonna see the complex number. And as I said to previously, complex number we can denote that one by C. So that stands for complex numbers. So we can say complex, and sometimes you can see this one like sharp. This one sharp stands for number. Most of people, they use this one sharp as a like a C sharp. C, that's a programming language. Sharp, it means that's a number. We can represent the number like that. So what is complex number? A combination of real and imaginary numbers in the form a plus bi, where a and b are real and I is imaginary. So a complex number is a plus bi. A and b are real. These two are real, and this is imaginary number. So that the set of real number and the set of imaginary numbers are subset of the complex number. For example, if we can put a I 1, we can put a 1 plus I. We can do that. Now that we know that what is complex numbers, what is real numbers, what is rational numbers. All right, so now we're going to visualize this one, the whole that we discussed. We discussed the complex number, we discussed the real numbers, we can discuss the rational numbers, we discussed the imaginary numbers, and we know also natural numbers, we know integer numbers, we know prime numbers, even integers. Now we're going to visualize this one, and now we're going to see this one. The first one that was invented, that was n, and then again now we have here we have integer, so that's integer, that's n, and now we're going to see this one's going to be inside the q, which is rational numbers, and all of them is going to be inside the real number. So that's how you guys going to visualize this one. So now you tell me, Mr. Yazdani, but you show us the complex numbers, which is I'm going to put it here, and where this imaginary number goes, because we also discussed the complex numbers and imaginary numbers. So, and I said the imaginary numbers are very useful. So where this one's, how we gonna visualize this one, and we're gonna put a joint here again, and this one's gonna, I'm gonna make this one's even bigger, because to make a room for my imaginary number. So I'm gonna put it all the way here, and here this guy imaginary is gonna sit here. That one's not very close to that one, so I should put this one away, and this one's imaginary number is gonna sit here. Alright, so now then if this imaginary number is sitting here, if this natural numbers, integer, we have rational numbers, we have a real numbers, then what is this all? This is a complex number. This everything sits inside the complex number. Natural numbers are subsets of integers, and this ones are set, all of them are subset. Whatever you guys going to see, natural number is subset of integer, integer is subset of rational numbers, and rational numbers subset of real numbers, and the real number is subset of complex numbers, and imaginary numbers also the subset of complex numbers. So the combination of real and imaginary numbers make up of complex number. The simplest example of I can give you. So whatever complex number we have here is the here, whatever you guys going to see here all, so the an imaginary number, so the combination of real and imaginary numbers makes up the complex number. This guy here and this guy here, if you look in here, so I don't know how I'm gonna, so here we have a real number and we have an imaginary number, they make up the complex number, the composite. So I'll gotta put it like that. Okay, so I'll try to draw again the combination of relational R, which is the real number, which is this guy here, and imaginary number, makes up the complex number equal to C. So that's how you visualize all this. Then that's all the set of natural numbers, and the first one is the universe set, and keep in mind that's U here, that's a universe set, and keep in mind that's empty. When we become empty, it means that there is nothing, our empty shell, there is nothing here. And that's, and this one here, that's the whole of the universe of these complex numbers. And complex numbers are made of imaginary numbers and real numbers, and real numbers contains the rational numbers, and contains the integer, and it contains the natural numbers. Keep in mind, natural numbers are the first one which was invented by humans. This one was the first one invented because humans used to count with the hand till the zero. It was invented, then they put a zero, then we move towards the zero, then we move towards negatives, and then we move towards the rational numbers, and then we move towards the real numbers. and then they realize that we need the imaginary numbers, and all of them comes inside the complex numbers, and the complex numbers is have real numbers and imaginary numbers. So in simple words, natural numbers are a subset of integer numbers, and integers are a subset of rational numbers. Rational numbers are a subset of real numbers. Combination of reals and imaginary numbers, or we can say that's a complex number. And sometimes you can see this one as integers as positive, which is this guy here. You guys going to see it as a z, and p means is the positives here. Say for example is 1 2 3 1 2 3 here inside your set, and sometime you're going to see that z star, and that's going to be non-zero integers. You guys going to see integers, say for example -2 -1, and it's going to be 1, it's going to be 2, but you don't see the 0. So when you see the z plus, it means that's positive, because you need all positive numbers, especially in computer science. And when you see that z star, it means that you guys -0. You don't see the 0, and it's going to be -1 -2 -3 all the way to infinity, and it's going to be 1 1 2 3 all the way to infinity. So that's going to be the z, and that's how you guys going to see. Alright guys, that's it for this video. If you guys have any question or comment, leave in the comment box. Otherwise, I'll see you guys in the next video, and bye.